Hello everyone, I am Raashi Patil. My roll number is 20EC10068. I am from the Chhattisgarh.
Hello, my name is Subhajyoti. My roll number is 20CS10064 and I am from Kolkata.
Hello everyone, myself Devendra. My roll number is 20CS10024 and I am from Udaipur, Rajasthan.
Hello everyone, I am Anuj. My roll number is 20 CS30005 and I am from Nagpur, Maharashtra.
This is our DIY laboratory group project.
We have made an automated curtain rolling system using the light sensors.
It works on the difference between the intensities of light inside and outside the room with the help of mechanical and robotic systems. We have also introduced the manual controlling option for rolling up and down the curtain according to our desire.
The motive behind the project is that people usually tend to turn on lights even in the daytime instead of rolling up the curtains and using natural sunlight. This project solves the issue by automatically rolling up the curtains in order to benefit from the natural sunlight during the day and rolling the curtains down when the daylight fades. There is also a provision to roll the curtains up or down manually using buttons in case if the user wishes to override the automatic control. This project will greatly help to save electricity spent on the lights during daytime.
And the project is structured, designed, and simulated on the following softwares. For designing hardware components, we have used FreeCAD and the circuit layout has been sketched on Tinkercad.
The schematic working of our project is as follows. Initially, the photosensors will detect inside and outside light intensities.
And then the Arduino will continue to compare both the light intensities and instruct the motor to rotate accordingly. This will make the motor shaft rotate gear A.
Gear A will in turn rotate the gear B and hence the axle connected to gear B will rotate.
Finally, the curtain attached to the axle will roll up or down depending on the direction of rotation of the motor.
There are two photosensors, one is inside the room and other is outside the room. Both the sensors will send their intensity data to the Arduino board. If the light intensity inside the room is less than the intensity outside the room, then the motor will rotate in anti-clockwise direction so the curtain will roll up. While the intensity inside the room is greater than that of the outside the room, then the motor will rotate clockwise so that the curtain will roll down. This has been simulated on Tinkercad. There are two modes of operation, automatic and manual mode. We can switch between the modes using the toggle button.
As discussed in a previous slide, we have used FreeCAD to design the hardware components of our project. Among these two gears, I have designed this gear A with 12 number of teeths, and for designing this gear, I have used involute gear option under part design and then modified it according to our needs, mainly using add a cylinder option, fusion and cut options under part. This gear will transfer the rotatory motion from motor shaft to the curtain axle using gear B. I have also designed the ball bearing, which will allow free rotation of curtain axle and support it from the wall. For designing this ball bearing, I have mainly used sketch and revolve option under part design, and for the small spheres, to multiply them, I have used array option under draft workbench, and I have set its dimension to coordinate with the curtain axle.
We have used FreeCAD to design the hardware components of our project. Among these hardware components, I have designed this gear B using the FreeCAD software. This is the gear B, which consists of 24 number of teeth. It is designed using the involute gear option under part design and modified using create a cylinder, fusion and cut option under part. This gear will interlock with the gear A and transfer the rotatory motion to the axle of the curtain. In this manner, the curtain will roll up and down depending upon the intensity of the light inside and outside the room.
We made this stand for holding our Arduino board against the wall. As you can see, these are the dimensions of our stand. Now that all our parts are ready, my job was to check the compatibility of these parts in various sizes and parameters and pick the correct ones so that they work in perfect symbiosis. I did this using the FreeCAD software. Here I imported all the files into this project and I just aligned them in perfect positions like to ensure that the threads matched, the ball bearings lied on the axle properly, and also and similar such rotation and translation etc. And I used these things. So now my structure was ready and the final part of my job was to animate them. That is to give that an idea of how our project will actually work in real life. So as you can see, it is rotating in this way. The two gears, the axles here, the stand here. The stand will contain the Arduino board, and from here it will connect it. So in this way, our project will work. Now I'll pass the bait to my friend Anuj, who will actually demonstrate the heart of our project, the code on which these gears are running.
Let us now see the hidden implementation details of the project. I have specially designed this circuit in Tinkercad to satisfy all the requirements of the system. This is a toggle key. It is used to switch between automatic and manual modes. It is by default in automatic mode. Here we have two photosensors. One is outdoor and another is indoor. Both these photosensors transmit the value of light intensities to the Arduino through pin A0 and A1. This is a DC motor. It is connected to a H-bridge motor driver. This driver is necessary to rotate the DC motor in both directions. The speed of the motor is controlled by adjusting the resistance of this resistor. These two are the up and down button for controlling the motor in manual mode. The Arduino is powered by a 9-volt battery. Let us now take a look at code behind this circuit. We'll just see the logic behind the code, as I have already explained the working of individual lines of code as comments. Here I have declared all the variables used in the program. In the setup function, I have declared pin 2, 6, 8, A0, A1 as input pins and pin 9, 13 and 11 as output pins. In loop function, the program first checks the mode of the system with help of the toggle variable. If the system is in automatic mode, then the code from line 33 to 67 is implemented, while if it is in manual mode, the code from 73 to line number 98 is implemented. Let us first consider automatic mode. First, the program takes as input the values of both photoresistors. Then it compares the values and also checks for the status of the curtain. The motor will rotate in only two cases. First, if the outdoor light intensity is greater than the indoor light intensity and the curtains are closed, then the motor will rotate in anti-clockwise direction to open the curtain. And second, if the indoor light intensity is greater than the outdoor light intensity and the curtains are open, then the motor will rotate in clockwise direction to close the curtain. To roll the curtain up, we first start rotating the motor in anti-clockwise sense using the digital right command. Then we wait for 10 seconds and then stop the rotation of the motor. Finally, we change the status of curtain to open so that our program can know that the curtains are rolled up. The code for rolling down the curtains is also similar. Now let us come to manual mode. In manual mode, the program first checks which button is pressed and rotates the motor in appropriate direction till the button is released. This means the user can roll curtains partially as well. Also, if the user presses both buttons simultaneously, then the program will stop the motor in order to avoid any potential damage. Now let us try to simulate our system. We can see the speed of rotation of motor here. It is currently 0 RPM. The photosensors are currently reading a minimum value. Now, if we change the reading of the outdoor photosensor to be slightly greater than the indoor photosensors, we can see that the motor has started rotating in anti-clockwise sense. It will rotate for a fixed amount of time and then stop. Similarly, if we increase the reading of the indoor photosensor to be greater than the outdoor photosensor, the motor will again start rotating, but this time in opposite sense, and again stop after some time. Now if we switch our mode to manual mode, we can see that any change in the reading of photosensor is not making the motor rotate. Instead, it has activated these two buttons, namely up and down. Now, if we push the up button, we can see the motor has started rotating in counterclockwise sense, and as soon as we leave it, it stops. The same happens when we press the down button. Just the direction of rotation of motor is opposite. So this has completed our simulation. Thus, we saw that the system is completely working. The only care that a user needs to take is while switching from manual mode back to automatic mode, we need to keep the curtains in closed position. That's it.
This is the assembled view of all the hardware components of our project.
While making this project, we came across various hurdles and we learned new things while overcoming them. For example, I came across various new features in FreeCAD such as geared workbench, geared designing, and also animation workbench.
We also learned to make custom Arduino circuits and also learned to code Arduino Uno board.
Also, we faced various challenges while making the project. For example, while animating the demo video, there were some issues in orienting the 3D objects while the animations were playing. Also, placing the objects, matching their parameters, and threading was quite tiring.
Proteus demo version would not allow us to create our own custom circuits, so we had to shift to an alternative, that is Tinkercad.
Thus, concluding our project can be a crucial part of home automation. This makes our daily lives easy and enables a fresh start of our day. Also, this can be a caring gift for elderly people. Thank
Thank
you.
Thank you.